Welcome. In this video, we are going to discuss about previous year NEET question in 2015 year in physical chemistry under the topic of some basic concepts in chemistry. Let's see the first question. What is the mass of precipitate formed when 50 ml of 16.9% solution of silver nitrate is mixed with the 50 ml of 5.8% NaCl solution? Basically, it is from silver chloride. Whenever silver nitrate is reacted with halogen, it forms a precipitate, white color precipitate. In this case, it is also white color silver chloride precipitate will form. What is the mass? They are asking what is the mass of the precipitate. Let's solve. How to solve this? They are asking the mass. Mass means in grams. We can find in a way of grams, or we can find in a way of moles, then convert the moles into gram. Anyway, anything we can do. Okay. Let's solve. First of all, what is 16.9% solution? Then 5.8% solution, then 50 ml. Okay. Answer is in the gram. Either we can solve by a gram way or moles way. First of all, we need to convert the ml into gram. This is a 16.9%. There is a two type of conversion. One is weight by weight percentage. Weight by weight percentage is gram. Unit will be same, gram, kilogram or kilogram. The another conversion is weight divided by volume, which is nothing but gram, ml or kilogram, liter. In this case, I am going to take this. Why I am taking this, we will see. Let me erase. Okay. Simply, we can solve it very simply. 16.9%, which means 16.9 divided by 100, right? 16.9 divided by 100. This is a percentage. What is this unit? Weight by volume, right? Weight by volume, which is in the unit of gram ml. I take gram ml, not a kilogram liter. Just take gram ml. Okay. Unit is nothing but gram ml. 50 ml of 16.9% solution. 50 ml. Okay. In the 50 ml. Okay. If we have a total container, right? Okay. Total container. If I am taking 50 ml from this 50 ml is made up of 16.9% of solution. This is a condition. Okay, the total can be 1 liter. In 1 liter, I am taking just 50 ml. That 50 ml solution is made up of 16.9%, or else containing 16.9% of what is called silver nitrate. That's it. So I multiplied by 50 ml. ml get cancelled. 50 multiplied by 16/9 divided by 100. We will get the number of moles. Sorry, number of moles is not, is in the gram of, is in the unit of gram. Okay. Finally, we found the gram of silver nitrate, which is nothing but 8.45 gram. Okay. In the case of silver nitrate, it is 8.45 gram. It's like same in the way we can find sodium chloride also. Okay, 50 ml of sodium chloride. It is also very simple. 5.8%. So 5.8 divided by 100 in the unit of gram ml, 50 ml, right? It is in the ml get cancelled. The answer will be 5.8 divided by 100 multiplied by 50. We will get 2.9 grams. 2.9 grams of, this is for silver nitrate. This is for sodium chloride. This much, which means they gave in 50 ml of 5.8%. I convert it into grams. That's it. It's very simple. This is just a unit conversion. Okay. Now from this value we can find answer, or else go to the moles way. I am going to that moles way because that is very simple in this case. Okay. How to convert the gram into mole? This is very simple. Moles is equal to weight divided by, which means given weight divided by molecular weight, right? Given weight divided by molecular weight. Okay. Let's solve this. Given weight divided by molecular weight. Okay. In the case of silver nitrate, the given weight is 8.45, right? Then the molecular weight of silver nitrate is what? Just add silver, 1 nitrogen, 3 oxygen, we will get the silver nitrate, which means the molecular weight of silver nitrate. Molecular weight of silver nitrate, if we add these parameters, we will get the molecular weight of silver nitrate is nothing but, I am taking rightly 8.45, then 2.9. Okay, I am right clearly so that we can see visible. 8.45, it is roughly 169.8. This is nothing but molecular weight. Molecular weight is in the gamma, in the unit of gram per mole. This is in the gram. Gram get cancelled, we will get the answer in moles. This is nothing but 0.0497 moles. Okay, right. In the case of NaCl 2.9, the molecular weight of NaCl, everyone knows the molecular weight of NaCl is nothing but 23 plus 35.57, which is nothing but 58.5, right? 58.5. It also has the moles, which means 0.0495 moles, right? When this mole of silver nitrate react with this mole, these are same, right? These are very small in difference, which means these guys have small difference in it. Okay, right. With this mole of silver nitrate react with this mole of NaCl to give what? What is the chemical equation? Silver nitrate, which means 1 mole of silver nitrate react with 1 mole of NaCl to give 1 mole of AgCl plus what? Sodium nitrate. It gives the sodium nitrate. Okay, this is 1, this is 1, so that it will be 1. So this is 0.0497, so this is 0.0495, then this is also in the intermediate is 0.0496. So the number of moles of silver chloride is 0.0496. I am taking the intermediate value. Very simple. Then what is the molecular weight of this? Silver chloride has the molecular weight 107 plus 35.5. If we add these two, we will get the molecular weight of silver chloride. So simply writing, okay, right. I'm rewriting this here. I got the number of moles 0.0496. Given weight I don't know, but the molecular weight is nothing but, if we add weight of silver and weight of chlorine, we will get 107 plus 35. It is nothing but 135 plus 7, which is nothing but 142, 143.3 something, 143.3 roughly. I multiply these two, I will get the weight, which means they are asking the mass of the precipitate. I will get it is roughly 7.02 grams. Uh, exactly 7 grams. Okay, this is a way to solve this question. This is a very difficult question, but we can simply thinking we can solve it. Initially we need to convert the 50 ml of this percentage solution into grams, then the grams is converted into moles by dividing it molecular weight. Then we will have the same number of moles in silver nitrate and NaCl. So 1 mole of silver nitrate gives, 1 mole of silver nitrate and 1 mole of NaCl react to give 1 mole of silver chloride. Just like 0.0497 moles, then 0.0495 moles gives the intermediate. I am taking the intermediate. So this is the number of moles. Number of moles is multiplied by molecular weight. Give the weight. Okay. Let's see the next question. If Avogadro number Na is changed from this value to this, which means the 10 to the power is decreases. Okay, this would change what? Avogadro number is basically what? Avogadro number tells what? Avogadro number is nothing but in one Avogadro number there is 6.023 in 10 to the power 23 molecules will be there. If it is a molecule, this much of molecules will be there. If it is an atom, this much of atom will be there. There is more than one atom. We multiply it by this atomicity. That is the rule. We already saw everything. Okay. In this question, what? Which means one Avogadro number, or else simply Avogadro number. Okay, simply Avogadro number, which is equal to 1 mole, because Avogadro number tells, okay, Avogadro number tells in 1 mole of a substance there is 6.023 into 10 to the power 23 molecules will be there. In the basic definition, which means the fundamentals of chemistry tells, Avogadro, a scientist, he tells in every substance, any substance, I am taking 1 mole. That 1 mole contains this much of molecules. But this is in molecules units. This won't change. If I take carbon, the 1 gram of carbon, 1 mole of carbon. 1 mole of carbon has 12 gram. Then 1 mole of nitrogen has 14 gram. But 1 mole of carbon has this much of molecules. 1 mole of nitrogen has this much of molecules. Molecules won't change for any chemical substance, any atoms, but the mass only changed. Okay, this is the Avogadro statement. Avogadro's only talk about the number of molecules or number of atoms present in 1 mole of a substance, not a gram. Hence, the answer would be, if I change the number of molecules, Avogadro's number, which means Avogadro's definition from 6.022 in 10 to the power 23 to 6.022 in 10 to the power 20, what would change? What will be changed? Okay, right. What is change? Simply the definition of mass in the unit in grams, or else what? Okay. Or else it changed this or this, because those two contains mass. Which one is right? Fourth option, the definition of mass in units of gram, that will affect our the mass of 1 mole of carbon affect, because the mass of 1 mole of carbon is affected. That option A is a good answer, or not option D. Okay, in 12 gram there is this much of molecules. Okay, if think reversely. If I take this much of molecules, it has this much of weight in grams. If we are reducing this factor into 10 to the power 20, the weight will be reduced, because these two are directly proportional to 1 mole is, don't consider the 1 mole. If it is there is a 1 mole, there is no 1 mole. 12 gram is equal to 6.023 into 10 to the power 23. Okay, acceptable. If the 6.023 in 10 to the power 23 is reduced to something, the 12 gram is also reduced. Okay, two factor will be reduced because there is directly proportional relationship. Then the mass of 1 mole of carbon is changed. This is the exact correct answer. Okay. Then this is a wonderful question, but this is very simple one. Okay, what is the mole fraction of solute in 1 gram of aqueous solution? In this case, the aqueous solution is water. Okay, water is a solvent, because solute, there is a one solute. Solute plus solvent gives solution. Okay, solvent is water, solute is something. We need to find the mole fraction of solute only. Okay, mole fraction requires number of moles of solute plus number of moles of solvent. Okay, we need to find the number of moles only. It is very simple. They gave only one hint. 1 mole. Every time small m represent mole. Capital M represents molar. Okay, here it is 1 molal. 1 molal is nothing but 1 mole in, which means 1 mole of solute in 1 kilogram of solvent, right? 1 molal represents, okay, there is a 1 mole of solute, so the number of moles of solute, sorry, number of moles of solute is 1. Here it is 1, here it is 1, we found. Then the only factor remaining is number of moles of solvent. It is very simple. Number of moles is nothing but given weight divided by molecular weight. Given weight is what? 1 kg. Write it in a grams, because the molecular weight of water is 18 gram. Just divide, what we will get? 1000 divided by 55. What is the value? It roughly 50, 50 some 55 something, right? 55.56, right? 55.56. 55.56. If we add this 55.56, here it is 1, here it is 1, here it is 55.56. Then denominator 1 plus 55.56 nothing but 56.56. In the numerator that is 1. So 1 divided by 56.56 is a mole fraction. Okay, it is nearly 0.0177. This is the answer. This is very simple question. Very simple. The number of water molecules is maximum. This is very fundamental. Okay, they are asking molecules. Okay, you can see clearly the fourth option, 18 molecules of water. Here it is 18 molecules. They are asking molecules. Here it is 18 molecules. Okay, we solve the fourth option. The remaining three options is left. 18 moles of water. Okay, what is the formula to find number of molecules? Number of molecules or number of atom? Number of molecules, it is nothing but number of moles, right? Number of moles into Avogadro's number. Okay, number of moles is 18 multiplied by 6.023 into 10 to the power 23. This much of molecules. Okay, this is in the positive unit. This is in the positive unit. This is very big value. Okay, right? Then 18 gram. 18 gram is nothing but 1 mole. Okay, the number of molecules is as the formula. 1 mole is nothing but 1 into Avogadro number. Okay, in option 2 there is a 1 into Avogadro number. In option 3 there is 18 into Avogadro number. Okay, 1.8 gram of water. 1.8 gram is nothing but 0.1 mole. Okay, 0.1 mole. So there is 0.1 into Avogadro's number. If you feel I'm solved this question very quickly from by this formula, you can watch my previous videos. I explained this formula very well in the previous many videos. Okay, you can watch that video. In option A there is a 0.1 Avogadro's number. In option B 1 time of Avogadro number. In option C that is a 18 times of Avogadro number. In option D there is just 18. Which one has higher? Option C is higher. So option C is the answer. This contains maximum number of water molecules. Okay. Then this is a final and interesting one. They gave weight ratio and they want molar ratio. Okay, I'm reading the question. The mixture of gases contains H2 and O2 gases in the ratio, which means weight by weight ratio. Okay, which is nothing but H2 and O2, which is equal to 1 by 4. This is nothing but a weight in grams, everything in grams. Okay, what is the molar ratio of two gases in the mixture? We need to find moles. Molar ratio is simply moles. What is the formula to find moles? Moles of hydrogen. In the case of hydrogen, it is nothing but given weight. What is the given weight? 1 gram. They are asking H2. Okay, H2. There is a 2 hydrogen. For 1 hydrogen, molecular weight is 1. For 2 hydrogen, molecular weight is 2. This is a moles of hydrogen. Then moles of oxygen. What is moles of oxygen? Given weight is 4. There is a O2 plus 16 plus 16, 32. Okay. Then we need to take the ratio, molar ratio of the two gases in the mixture. Just like same H2 and O2. So we need to take these two ratios. Very simple. If we take the ratio from this two, what is the answer? Okay. Simple, 1 by 2 multiplied by 32 by 4, and this goes upward. Okay, 16, 4, 1 is to 4 is the answer. 1 is to 4 is the answer. Very simple. Okay, 1 is to 4 is the answer. So option C is answer. Okay, the first problem is very difficult problem, but yeah, other problems are very simple.